Hello everyone, this is Jayalakshmi, working as an assistant professor in the Department of Electrical and Electronics Engineering in SRM Madurai College for Engineering and Technology, Madurai. In this video, I am going to discuss about the importance and introduction to the power electronics subject. Let's start with the definition of power electronics. What is power electronics? As the word says, power electronics, so the electronics controls the power, or we can define power electronics is the application of solid state electron devices and circuits to control and convert the electrical energy. So the power electronics plays a major role in our day-to-day life. If you take any electrical appliance in our home, starting from the mobile charger or laptop charger or refrigerator or the smart TV, water heater or the UPS, everything will be having the power electronic equipment within them. So best example we can explain with the inverter or the UPS, where the available AC source will be converted into DC using a AC to DC converter to charge the battery, and there will be an inverter which converts the DC to AC to give supply to all the appliances when there is no power. So without the power electronics, a single day is not even imaginable for all our life routine. So now this is the basic block diagram of any power electronic system. So you have a power processor in between the source and the load. So power processor is nothing but it is a power converter, like AC to AC converter or AC to DC converter or DC to DC or DC to AC converter. Depends upon the load requirement and the source availability. We can choose any one of these converters, AC to AC or AC to DC or DC to AC or DC to DC. And the next important block in this diagram is controller. So the controller is nothing but it can be an analog controller or digital controller. It will get the feedback signal from the load, and based on the reference signal and the feedback signal, it will control the power processor. So controller is nothing but it may be an analog circuit or it may be a microprocessor or microcontroller based system. So next we see the interdisciplinary nature of power electronic system. Power electronics is an interdisciplinary field that blends electrical, electronic and control engineering principles to efficiently manage and convert electrical power. So mainly it focuses on using semiconductor devices and circuits to control and transform electrical energy between different forms, which is very crucial for the applications like renewable energy, electrical vehicles and smart grids. So the figure shows the interdisciplinary nature of any power electronic system. The knowledge of circuit theory, electrical machines, power systems and electromagnetics, these are all very crucial for designing the power circuit. And the knowledge of solid state physics, electronics is very essential for designing a converter circuit. And the system and control theory, signal processing, simulation and computing, these areas are very important for designing a control circuitry for this power electronic system. So power electronics is not a single subject. If you want to design a power electronic system, you need to have a deep knowledge in all these areas. Then only the system what we design is efficient and it will do the purpose for what it is designed. So the next slide we will discuss about the power electronics applications. Power electronics has a wide range of applications across various sectors, including consumer electronics, industrial equipments, renewable energy systems and transportations. So basically we can divide them into commercial applications, domestic applications and industrial applications. So as far as commercial, lighting, heating, air conditioning, central refrigeration, lot of areas we have for commercial applications. In the domestic applications, the appliances whichever we are using at home, like AC or fridge, or if you take a UPS system or mobile phone chargers or laptop chargers, everything will be having a power electronic equipment embedded inside it. And in case of industrial applications, we have pumps, blowers, fans, all those things will have a power electronic equipment to control the speed. To have a variable speed drive, we need to have the power electronic based system only. So also we can have the applications of power electronics in the aerospace also, where the power supply systems for space shuttle, satellite power systems or aircraft power systems, everything is based on power electronics only. And in case of telecommunication field, the battery chargers, power supplies, mobile cell phone battery chargers, everything is based on or having power electronic equipment. In case of transportation, today the emerging trend is electric vehicles. Wherever we go, we see EV, electric vehicle, electric auto, electric car, electric bike. So these tremendous change in the transportation is not possible without power electronic equipments. So using the power electronics only, the traction control of electric vehicles, battery charges for electric vehicles or electric locomotive, everything is designed. And so the major application of power electronics we can say is the electric vehicle in the current trend. We can say surely about it. Next thing is utility system, like high voltage DC transmission, where power electronics plays a very crucial role. So next we will see the various solid state devices that can be used as switches in the power electronic circuits. So the main devices are power diode, thyristor, power transistors, MOSFET, GTO, IGBT. And we know very well a power diode will be acting as a closed switch when it is forward biased, and it will be acting as an open switch when it is reverse biased. That's why we call it as uncontrolled turn on or turn off. No separate mechanism is required to turn on or turn off. Based on the supply, it will be forward biased or reverse biased. Whereas thyristor, if you provide gate pulse, it will be turned on, and turning off of thyristor requires separate commutating circuits. So we can say controlled turn on and uncontrolled turn off for a thyristor. And the devices like transistor, MOSFET, GTO, IGBT, they have both controlled turn on and turn off characteristics. That means as long as the input gate signal or the base signal is there, the device will be on. Once the gate signal or base signal is removed, base current is removed, the device will be turned off. And the devices like BJT, MOSFET, IGBT, they all have continuous gate signal requirement. That means the gate signal should be continuously there. The control signal should be continuously present, then only the device will be on. But in case of thyristor or SCR, when the thyristor is turned on with the gate pulse, then even if you remove the gate pulse, it will be in the on condition only. And we can say they have the pulse gate current requirement, SCR and GTOs. Also the devices like SCR, GTO, BJT, MOSFET, IGBT, they all can conduct the current in only one direction. So we call them unidirectional current capability devices. But TRIAC is the only device that can allow the current flow in both the directions. So we call it as bidirectional current capability device. So now we will see the various power electronic converter circuits. We have four major categories like AC to DC converter, DC to DC converter, DC to AC converter and AC to AC converter. In case of AC to DC converters, there are two different types: uncontrolled diode rectifiers and controlled converters. Uncontrolled means we will be using diode, so we call it as uncontrolled diode rectifiers. And when we use SCRs as a switches, it is called AC to DC converter or controlled converters. Here there are different types like fully controlled converter, semi converters, half controlled converters. So the operations we will be discussing later. And in case of DC to DC converter, also called as choppers, there are different types like a step up chopper, step down chopper, step up down chopper. And in case of DC to AC converters, which are also called as inverters, we have classifications like voltage source inverter, current source inverter. And in case of AC to AC converters, there are two different types, AC voltage controllers and cycloconverter. In case of AC voltage controller, only the output voltage is changed and the frequency will be same as the input frequency. In case of AC to AC converter, both the output voltage and the frequency can be controlled. So even though we say power electronics plays a major role in all aspects of electrical engineering, it has its own demerits like harmonic injections, low overload capacity, it has lagging power factor operation, and there are regulation challenges and EMI issues, electromagnetic interference issues, and the cost involved is more due to the introduction of converter circuit and control circuit, and complexity is also increased due to the control circuitry. So in this video we just see what is power electronic system, what are the basic components or basic building blocks of any power electronic systems, and the different converters available, and what are the applications of power electronics in different areas and their demerits. And in the coming videos we will see one by one in detail. So thank you everybody for listening this video patiently. Hopefully this will give you a basic detail about power electronic systems, and we will meet you with more informations in the coming videos. Thank you.